So today on the bench I'm working on a Sansui G-5500. I guess the magic smoke has been let out of this thing, so we're going to have to try and put it back in. It seems in very good shape. All the controls feel good. Doesn't appear to be anything missing on it, so it seems like it was very well taken care of. I guess now we just have to open it up and find out where the smoke came from. So stay tuned. Alright, so I'm just going to be taking a quick glance over this to see if I see anything that pops out at me. Oh yeah, I think I see where the magic smoke come out. Right in here. Looks like we lost a resistor or a diode or something in here. Looks a little crunchy. It seems to be near the final output board where the final output transistors are soldered to, so I'm gonna say that we most likely have some finals that are output transistors that are shorted out or no good. We'll have to check the emitter resistors and the surrounding circuit to see what we got here. The other side looks okay, so that might be functional. I don't know yet. So all 6 transistors just drop their leads down to the board on each side, so I can test them here at the board instead of on the main board. I can test them on the little sub board that's mounted to the heatsink. And I'm just checking for a short across emitter, base, and collector on each part. Nothing there. Nothing there. Now, you know, you will want to do a diode check on these after. I'm just doing a general short check right now. Nothing there. Oh. Nothing there. There's a short. Alright. So that looks okay. 58 ohms on there. Yeah, we got some issues on this channel for sure. Got 50 ohms reading across this part, and we got a short on this part. So there's definitely some issues on this board. These 2 power parts, one of them's definitely shorted. The other one I believe is on its way out, possibly, or it's being pulled down from the short on this side through the board. And I think the first thing we'll have to do is take this board off of here, unsolder these wires to the outputs, and start checking the components that may have failed on the main board down here that drive the outputs. Okay, so those are all separated. Now we can pull the board off. And these screws weren't all that tight either. Okay. So now that other... So there's the module, well, if you want to call it that, but this may even be a diode. I'm not sure what they're using here for temperature sensing, but that just came off without even any effort because it wasn't really fastened. The screw goes to this little hook here. So this is sync and focus. Come on. So yeah, well, we can test these transistors out of circuit, and we can clean up the board if we get a, put new transistors in. Makes it a little bit easier than trying to do everything buried down in here. And we can just reattach the wiring once we're ready for that. Okay, so I have the board on the bench with the components in them. Now I'm going to be testing for shorts here on the multimeter. I have it in diode check. Let's check this component. Oh yeah. Dead as a doornail. So she's shorted there. This one's no good. And this one as well. Not good. So we're going to have to definitely replace these components and look on the board that these are attached to, because I am sure there's going to be issues down there. As we already know, we have some burnt out components. Okay, so we need to replace these, and these are 2SC2580, and the other one is an 2SA1105N. One's a P part, one's an N part, and these are not the original parts that were in the receiver when it was manufactured. These have definitely been replaced before, and that definitely confirms why maybe this was loose. I don't think the assembly was all that great when they did that. So let's see what we can replace these with. If we can't find C2580 or 1105 in stock, we can use other components. So let's take a look on NTE's website here and see what crosses to these components. Alright, so we have a 2SC2580 crosses over to an NTE36. And the 2SA1105 crosses over to an NTE37. What I have, let's see, go over to this other one here. Now these two components. We have a B688 and a D718. Let's go back to the other page here. And let's check those out. So we have a B688, and that crosses over to an NTE37, and we have a D718 that crosses over to an NTE36. This is how you can, let's go back here. This is how you can try and cross other components that you may have in stock to see if it's compatible with the components you're taking out. It doesn't have to be the exact same part number, it just has to be similar specifications. Alright, so it looks like the person that installed these didn't really care about his work, because he left all the rosin, flux, crust, crap all over the board and just wanted to get his money. You gotta take pride in your work, this is just lousy. I don't like to see this. Maybe it was for himself, maybe he just didn't understand or don't care, but you never want to do this. You want to know why? Because this becomes conductive after a while, and see it growing in between these leads? That can cause you shorts on your components over time. If these become low resistance, they will change the characteristics of this connection. So yeah, never leave it dirty, because it could cause you an issue down the road. Maybe not for 5 years, maybe not for 10 years, maybe never, or maybe 2 years, but eventually it could cause some issues down the road and change the resistance a bit. So we're going to clean this up. We're going to get these old components out. Okay, so what I like to do is start with a little bit of fresh solder. Well, that component was barely even soldered. Did you see that? Ay. Alright. Just going to add a little bit of fresh solder there. And then I'm going to wick it up. And a little bit some fresh flux. Just so I can, whenever you use the solder braid, a little bit of flux helps. That center connection, probably get away with using the solder pump because there's a lot there. And might as well, whoops. Love it when that happens. Get a little bit off here. And you could buy these solder pumps online. Amazon or anywhere. I really like the solder pullet. That works really well for me. If you buy the cheap ones, they don't work all that well. This is a model DS017. I got like 5 or 6 of these at a ham fest one time, and I scooped them up for like 50 cents each. They're like $30-something a piece. They're not cheap. Alright, so this is ready to come out. Still got a little bit of foot growth there. Okay. Okay, so I got one hanging on for dear life here. Let's see if we can try and melt it out of there a little bit. Okay. Alright, so now we can clean that up. I'm going to take a little bit of alcohol and a toothbrush. And I'm just using some cloth. It's actually a lens cleaner tissue. Works very well. It's going to tear apart. I'm just looking to get the bulk of this crap up. So I want to get rid of more solder off of these pads first. And these other pads that have the holes in them, that's where the wires were inserted with those little wire inserts. Okay. And now we can try and get in there a little bit more. And the tissue actually helps from spraying this stuff all over your bench. Probably wouldn't be good to use in a static sensitive board. But I've done it with no issue before. Well, that's looking a lot better already. I don't see anything stuck. That's good. We'll be ready to put a new part in there. So we're just going to do the same thing to the other side and get ready to put the new components in. So the board is cleaned up and I've inserted the new parts. I just bent the leads and put them in. Got all the flux off the board. And here's a little tip, is put the screw in that was holding the board to the heatsink in the back, so when you go and solder these components, the hole will line up after you solder it, so you're not bending the part to force it into place so it can't move. So we're just going to have to solder these in and just make sure you put the right ones in the right places because that matters. So now I'm just going to add a little bit of flux to these legs. Nice clean tip. Add a little bit more solder just to make it look uniform. And the new flux comes off way easier than the old flux if you do it right away. You don't want it sitting on the board, because it gets hotter as it dries and turns into a nightmare to get it off. So it's a lot easier to just get it off after you solder it. Nice and shiny. So I'm going to just check these components after they've been soldered. Pretty sure they're going to be good parts. I just want to make 100% sure. That's good. That's good. That's good. That's good. All right, so now I feel confident that this board is set to go. Okay, so now we're going to be ready to put the board back on with the 2 transistors. But before we do that, we want to clean some of this old heatsink compound because it's getting kind of crusty and nasty. And there's a mica insulator that goes between the transistor and the heatsink that insulates electrically. So it won't short out against the heatsink, but also allows the thermal transfer from the transistor to the heatsink to occur. So we're probably going to have to definitely do this channel as well. It looks like somebody's been in here because they get a whoops mark right here. A little bit of a burn on a wire. So I also saw something that concerned me on this board here. See if we can zoom in here. Is one of the legs of the transistor here is becoming a little partially unsoldered or corroded. So we're going to have to probably resolder that board as well and take this off and regoop the transistors on the heatsink. If that side's dry, the side's probably is as well. And I did some probing around here and I found the components that are no good. This was a resistor. This is a resistor. They're both open. This one's open. This transistor is shorted, and this resistor is open. This resistor is open, and I think that was it. And obviously these 2 were shorted, and I can't remember if there was anything else. I think that may have been it. So we're going to have to check all these components in the circuit. It's going to take some time and make sure there's nothing else going on. Yes, because when we put our new parts in, we don't want the same thing to happen once we turn it on. So that's it. So these are the 2 bias and 0 adjustment. The biasing, we're going to go through that once we get the new components fitted, and the 0. And same thing on the other side. We're going to test the other side to make sure that that is still within spec as well. So I'm going to try and get these old components out of here and start cleaning up this board. We're not going to be able to clean up the burn mark on the board. We can to some extent, but once it's burned through the board or burned into the board, you can only clean out as much as you can. The only problem is sometimes it becomes conductive if it's too far, if it's really damaged. So we'll try and scrape out as much as we can so we can actually still utilize the position on the board to put our new part in. So I've already unsoldered this because I know this is going. So yeah, so that's the next step, is start yanking out all the bad components. So I've taken the board off and I've cleaned off the transistors. I've taken the old dried off heat compound off. I've resoldered the connections to them, so those are all nice again. I've cleaned the heatsink, so everything's all nice and fresh. I've even wiped down the mica insulators. So that's important that you get all the dry crap off it, because if you have a crunchy bits in there and you try to put it in there, you can risk cracking this or not making good thermal connection, which is all bad. You also have to watch out when you clean these. These things are like brittle glass. If you want to put it on something firm and flat to clean it with. You put a napkin down on something flat, and then you put this on top of the napkin, and then you just clean with a Q-tip, get all the old crap off with alcohol. Alright, so what we're going to do is get this onto here. Doesn't matter which way you do it. You have to put between the transistor and the mica, you need some of that heat compound, and between the mica insulator and the heatsink. You don't need a lot, just a dab will do, because it will spread out once you squeeze everything together. So I like to just put a little dab there. Just kind of just mush it around a little bit, flatten it out. Kind of like that. And get the other side. I'm just dabbing it on and moving the nozzle of the heat compound to spread it around a bit. You wouldn't want to use a Q-tip in this step, because all those little frillies will come right off and get in there. So I find that flattening it out with the nozzle of the heatsink compound works pretty well. Okay, so now we're going to take our insulator. Just put it on there like that. Give it a little squeeze. Try to line the hole up. And if you did your spreading out really well, you'll see that there'll be no gaps between, because you can see through the mica insulator. You'll see that you've spread it evenly enough. When you squeeze it, it will spread. So I'll just do the other side. So it should look just like that. And now, since it's kind of a little tricky to get this down in there and put that on there, you could do it other ways. I'm just going to put it on here. And you're going to be a little bit easier with it, because you can slide that insulator around a bit. You don't have to go too crazy. If you go like this, if you try to stay just a little bit inside the edge, because if you go all the way out to the edge, believe me when I tell you, once you squeeze this to the heatsink, it's going to spread out. Okay, so that's good. It'll look just like that. And at this point, they should stay in place. And now this is the tricky bit, is trying to line everything up. So I'm going to put a screw through here. Okay, that's started through. Now I'll get the other one started in there. If you do your job that good, they just fall out. So I'll just move the insulator a little bit to catch a thread, and it should hold it in there till you flip it. Okay. So now I want to get those as close as possible to where they're going to live. Now you can line up the screws before you actually make contact with the heatsink. That way you'll know you're lined up. Start the screws. So I'm just going to start pulling these in a little bit. And then press the board up against it. Should be nice and smooth, you'll feel it. Okay, wiggle it just a hair and send the screws home. Okay, so we're just going to do that to the other side and hook up these wires back up, and then we can start working on this board, get all that stuff out of there. Okay, so now I'm just going to replace these 1/2 watt resistors here. I got a couple of ceramic insulators on them. Just bent the leads and put them on. Install those. Okay, so what I've found so far is these two output transistors were bad. They are now replaced. They had an NPN and a PNP. They're now on the heatsink, and this varistor is now firmly fastened to the heatsink. This is very critical to keeping the bias stable, because it's definitely, so is the bias adjustment right here. It goes through the bias adjustment and through that varistor, so I'm sure that that's some kind of compensation for the biasing. This TR20 was shorted. This is the protection, DC protection, overload protection transistor that monitors this output section, and these accompanying resistors were opened up and fried. Those are the ones that were barbecued there, and I think the other one was maybe was it R10? I think that was cooked up too. Let's see, these two emitter resistors are opened up, or one of them was opened up. I think 1 or 2 of these were opened up for these two pre-drivers, and I think that might be it so far. So I'm going to replace these parts, and I'm going to try and attempt to power this up, and hopefully we don't let more magic smoke out. Okay, so we're about to fire this off, and hopefully we don't let any smoke out. So right now I have this hooked up to the oscilloscope, both channels, so when I kick this thing on, if any DC is presenting itself out to the speaker terminals, I'll know immediately, and I'll be able to turn this thing off because I know there's more issues going on. I have it also hooked up to my isolation transformer. It's got like a 5 amp breaker on it, so if something really bad's going on, it'll just pop that, and hopefully it won't start burning stuff up. So here's all our components over here, just floating around in the breeze. That's what we've taken out. And okay, so it's I assume it's repaired at this point. So I'm going to turn it on. You know, no matter how long you've been doing this, I don't care who you are, this is the most nerve-wracking point in the repair, because this could just blow up in your face and you'll have to start all over again and spend more money on parts and blah, blah, blah. It's just nerve-wracking. So, let's just do it. Let's power it on. I got my finger on the power button, so if something doesn't happen, something bad happens, I can take it off. There's a little bit of a delay in this, so once this thing turns on, it takes about 5 to 10 seconds for this relay to kick in, which connects the speakers to the outputs, to the output terminals. So that will connect the speakers to the amplifier section. If there is a problem, hopefully it will just stay off, but we don't know the state because we had some trouble in that protection circuitry, so we want to make sure. So if there's any DC on that scope right there, I'm immediately going to be killing this thing. It should fluster or flutter a little bit when it kicks on, which is completely normal, and then it will settle back down. All right, let's go. Let's do it. Come on, kick in, kick in, kick in. Nice. Excellent. As Dave Jones would say, winner, winner, chicken dinner. Awesome. That's great. All right, so now we can finally start biasing up the outputs, get that all straightened up, and we got no DC. This is great. Both channels are here. Excellent. Okay, so we're back to the service manual again for the bias instructions, and we're going to see the adjustments. So right here is the DC 0 volt adjustment and the bias current adjustment. So we're going to want to hook a voltmeter up to here on these two emitter resistors on this channel, and then we'll have to move it to the other channel. But I'm only going to show you one channel because it's exactly the same. And the two variables are here and on the other side. Okay, so I have we're going to have a voltmeter hooked up on the output between the speaker terminals, plus and minus, and we're going to have the bias adjustment. We're going to have this set up here. So we're going to be measuring for 0 volts on the output of the speaker channel, and across those two emitter resistors, we're going to be looking for 5 millivolts. And if we don't, we're going to have to tweak these potentiometers, and hopefully they respond and move down or up according to our chart here. So let's get to do that. Okay, so those two variables are right here and right here, the two blue ones. And this is a do as I say, not as I do type of moment, because I'm an educated idiot and I'll use a metal screwdriver to adjust these, but they are plastic potentiometers. So let's go up to the meters here. This scope meter here is measuring the millivolts on this across the speaker terminals there, and this meter up here is going to be measuring the millivolts across the emitter resistors. So right now we have 5 or 6 millivolts on the output terminals on the speaker, which is not terrible, and we have 4.3 millivolts here on the across the emitter resistors, which is also not terrible. I don't know if we're actually going to get better than that, because these things can be very touchy. So let's try and see if we can get that millivolt reading down on the output speakers, output terminals. And let's see if it jumps around a bit. You want to have this on for at least 5 to 10 minutes before you make these adjustments, by the way. Okay, that just jumped up. We don't want to go there. 8, 7, 4, 27. Wow, that is touchy. Oh, 0.4. Leave it alone. Walk away. Okay, that's perfect. Now this is climbing up. This is about 4.5. Let's bring that up just a hair. Down. Oh man, that's so touchy. Right there, that's fine. This is not a very cool, fine adjustment at all. Yeah, I mean, I'm literally rust a screwdriver on it and we'll go down to 4 something. Yeah, okay, so that's probably as close as I'm going to get that. That is completely fine. Of course, I'm a perfectionist and I'm going to go at it till it stays. Wiggle it around a little bit. That's it. Walk away. Alright, so I'm going to do the same thing to the other side, and we should be able to throw a signal into this. So, alright, let's bench test this puppy. So then get the meter hooked up to the outputs along with 2 speakers up above, to 2 8-ohm speakers in the output, scope monitoring the output as well. I'm going to have my arbitrary waveform generator setting a signal out to the amplifier's aux input via 3 millivolt peak to peak 1 kilohertz. And I have these 2 offset so I can actually see both waveforms. Alright, so let's turn on the amplifier. Actually, the amp is already on. Let's turn the signal on. Let's turn the volume up. Balance in the middle. Excellent. Let's go left. Right. Left. Beautiful. So now I'm just going to let it set and burn in for a little while, and play this test tone into those speakers for maybe a half hour to an hour, maybe.
Sorry, I don't know that one.
Shut up, Alexa. So yeah, that's it. I hope you guys enjoyed this video, and we'll see you in the next. If you like what you see, come on back. Hopefully I'll have some more stuff soon. And that's about it.